In this video, we are going to demonstrate an example on how to find the equation of tangent plane and also normal line given a surface. Okay, so specifically for this example, the point that is given to us is -2, 1, -3, and the surface, the ellipsoid given to us is given by this equation, x squared over 4 plus y squared plus z squared over 9. So two things that we need to determine in this question. The first one is the equation of the tangent plane, and then the equation of the normal line at that particular point given to us. So we need to understand the problem first. The ellipsoid given to us, okay, is the level surface, okay, with k equal to 3. Okay, let me put a note here. Ellipsoid, okay, is the level surface, okay, where we have k equal to 3. Okay, and the function, okay, from this equation, we have the function given by f x, y, z, function of three variables, that is x squared over 4 plus y squared plus z squared over 9. All right, and from here, we are going to find the partial derivative. Okay, first with respect to x, and then respect to y, and then with respect to z. So I think this is easy. We can go a bit faster. Okay, f sub x, x, y, z. So we need only to focus on the first term on the right-hand side of this equation. That is x squared over 4. And what we are going to have is x squared, you'll get 2x, okay, over 4, and that will be equal to x over 2. And then we have f sub y, x, y, z. Focus on the second term here. So on the y square, we have 2y. Okay, and then the third one is fz, x, y, z equal to, okay, focusing on this, we have 2z over 9, right? So we have all those three. And of course, the next step is to find the grad f, okay, the partial derivative at that particular point given to us, -2, 1, 3. So let me put a divider here. So we have f sub x, -2, 1, 3, and then f sub y, -2, 1, -3, and then f sub z, -2, 1, -3. Okay, combination of them, of course, is what we call as grad f or del f. Okay, so the first one, we have x over 2, and our x, okay, the point at the point is -2, so you just plug in -2 over 2, that will give us -1. And then similarly for second term, we have 2y, 2 times 1, that will be equal to 2. And the third one, 2z over 9. So you just plug in z equal to -3, and then you get to -2 over 3. So we have all the values required, okay, to construct the equation of the tangent plane. So the equation tangent plane is given by this formula. I hope you still remember the formula. That is, first we have f sub x, okay, or let me put here f sub x, okay, and then we have x minus x naught, okay, I can put the formula first, okay, plus f sub y, y minus y naught, plus f sub z, z minus z naught, and this one is of course equal to 0 here. All right, and then you can plug in the values. We have f sub x here is when we consider the point lah, -2, 1, 3. So what the value that we are going to have here is -1, and then we have x minus -2, that will give us x plus 2. Okay, and then second one we have plus 2 for f sub y here, and then y minus 1. Okay, and then we have -2 over 3, -2 over 3, z minus -3, or z plus 3 equal to 0. And of course, the last thing that you can do here is you can simplify. And then you'll get to 3x plus minus 6y plus 2z plus 18 equal to 0. But I think the process from this line the second last line here to the last line is easy, right? It's just a basic arithmetic operation. Okay, so that you can reach to something that you are familiar with, the equation of a plane. In this case, the equation of our tangent plane at the point -2, 1, -3. So we are done with the first part of the question. The second part of the question is to find the equation of the normal line. And of course, we are going to use our previous knowledge on vector and how we can construct. So one way is by using the symmetric equation, where we need to know the grad of f, or the vector for the normal line. So the normal is to the plane, right? So the line is the equation will be something like this. Okay, let me put the proper way to the name. Symmetric equation, or equations on, in this case, because we have three. Okay, first one is involving x, and then involving y, and then involving z. So symmetric equations of the normal line are given by, okay, the first one is x plus 2, okay, over f sub x -1, and then it will be equal to y minus 1 over f sub y, that is 2. And then the third one is z plus 3 over -2 over 3, our f sub z. So this is our second, our solution, or our answer to the second equation in second problem in this the main problem given to us. Okay, we have two parts like I mentioned earlier, the equation of tangent plane, that is this one, and then the the equation of the normal line that we obtain here using the symmetric equation. So sometimes you might be asking me, can we use the parametric equation involving t? My answer is yes, if I don't specifically mention that you have to write the symmetric equation. So any kind of equation work here.